Hello and welcome to this TTA TV video. When we capture photographs, the person's size in terms of how much it takes up on the photograph is affected by how close or far away they are from the camera lens. If we take this concept of a person's photograph being taken with a large building in the background, the scale of the building in relation to the person will be affected depending on how far away it is or how near it is. This effect can be seen very clearly in a photograph on the right hand side, which is captured from ground level looking up at the Empire State Building in Manhattan in New York. The Empire State Building was built in 1930 and is 102 stories high. We're going to focus in on a particular aspect of this by looking at the windows and how this perspective feature in the photograph distorts what we think in terms of size. If we look at the windows which are near the ground, they take up more of our field of vision, and therefore their actual size is seen more accurately. But as the windows go up the stories, particularly near the top, they take up very little of our field of vision. And this effect makes us look at the windows appearing smaller in our field of vision. Perspective is often used by artists or architects to convey what an object or a building would look like in real life. However, perspective is not appropriate for the construction of a building, as it does not show the proportional lengths, widths and depths of various aspects as it's being constructed. A more accurate form of drawing is known as orthographic projection, which does maintain the relationships between height, width and depth on a drawing. The term orthographic originates from the Latin word ortho, which means perpendicular. This concept of perpendicular will become evident as we explore orthographic projection further throughout this video. In orthographic projection, if we view a shape, we view it with the lines of vision being parallel to each other. This means that no matter how far away or close the object is, its dimensions remain constant. In Europe, the standard orthographic projection is known as first angle orthographic projection. This concept means that the observer or the person looks at an object and projects an image of that object onto a plane. To see this in action, if we take a look at this cube which is floating in space, and it has planes behind it and underneath it. The plane underneath the cube is known as the horizontal plane and is horizontal, and the planes to the back of the cube and the side are vertical planes. Now, as we study orthographic projection, we'll understand that the intersection of the horizontal and vertical planes is known as the XY line, and this can be seen in red on screen. If we were to stand in front of this cube and project parallel lines so that they continue until they hit the vertical plane, we are then able to create a projection of what the front of the cube looks like on that plane. Likewise, we can repeat the process if we're looking in from the side. Again, we project perpendicular to the plane, and any lines that are parallel remain parallel. Finally, if we were to take a bird's eye view and look downwards, we can project onto the horizontal plane to get a plan view of the cube. This is what's happening in a three-dimensional world. Of course, when we are drawing and using our drawing equipment, we're using a sheet of paper which is flat. So to convert this to a two-dimensional drawing sheet, we can hinge the intersection lines between the planes. For instance, the vertical plane and horizontal plane can hinge along the XY line, and the two vertical planes can hinge so that they line up left and right. On our drawing sheet, this is why we construct the orthographic views in these positions, and the projections of the object can then be placed accurately on the various planes. That's all for this video, and as always, we'd like you to subscribe to the TTA TV channel for more videos like this. Thank you for watching.